In the highlands of East Africa, where ancient volcanoes once shaped the land, where fertile soils once fed empires, there came a time when the rain simply stopped. This is the story of the 1983 to 1985 Ethiopian famine. But this is not just a story of hunger. It is a story of geology, of climate, of fragile systems, and of human endurance when the earth itself grows silent. Before the famine, there was abundance. The Ethiopian Highlands rise like a fortress above the Horn of Africa. Carved by lava flows millions of years ago, shaped by tectonic forces from the Great Rift Valley, this land is geologically ancient and agriculturally vital. The soil here is volcanic, rich in minerals, dark, productive. For centuries, farmers relied on seasonal rains. There were no massive irrigation systems, no industrial food networks, no engineered safety nets, just rain and faith. East Africa depends on seasonal monsoonal systems driven by the Intertropical Convergence Zone, ITCZ, Indian Ocean temperature gradients, subtle atmospheric oscillations. When the ITCZ shifts north or south, rain patterns change. Normally, this shift is predictable. But in the early 1980s, something changed. In 1982 and 1983, global climate systems destabilized. A powerful El Niño event formed in the Pacific. Ocean temperatures shifted. Atmospheric circulation altered. Rainfall belts moved. The rains that normally soaked the Ethiopian highlands weakened, then failed, then disappeared. Fields that once shimmered with teff and sorghum turned to dust. Rivers shrank. Wells dried. Cattle collapsed. This was not sudden. It was slow. A creeping silence. The Ethiopian highlands are geologically blessed, but ecologically vulnerable. Decades of deforestation, overgrazing, soil exhaustion, population growth had weakened the land's resilience. Without vegetation cover, rain, when it did fall, ran off quickly. Topsoil eroded. Moisture retention declined. The land could not store water. And when the rain stopped entirely, there was no buffer. The geology that once gave life now revealed its limits. Volcanic soils are fertile, but only when water feeds them. Crop failure came first. Then livestock death. Then food markets collapsed. Then migration began. Families walked for days, sometimes weeks, searching for relief camps. Children weakened. Hospitals overwhelmed. Entire regions faced starvation. An estimated 1 million people died. Not from war. Not from earthquake. Not from volcanic eruption. But from the absence of rain. While drought triggered the disaster, other forces amplified it. Ethiopia at the time was under political upheaval. Conflict disrupted distribution. Infrastructure was limited. Transport networks were fragile. Even where food existed elsewhere, moving it to remote drought-stricken regions proved difficult. This is a crucial lesson. Natural disasters rarely act alone. They collide with human systems. And where systems are weak, tragedy multiplies. In 1984, international journalists broadcast images of skeletal children and overwhelmed camps. The world reacted with horror. Music concerts were organized. Global fundraising campaigns mobilized millions. Relief aid poured into Ethiopia. Airplanes carrying grain landed on dry runways. Doctors and volunteers crossed continents. The famine became a global awakening. For many in the West, it was the first time Africa's environmental vulnerability was seen on television screens. But behind the images was a deeper truth. This was not just poverty. It was climate vulnerability intersecting with fragile land systems. Drought is not merely lack of rain. It is imbalance. Meteorological drought, when rainfall is below average. Agricultural drought, when soil moisture declines. Hydrological drought, when rivers and aquifers shrink. Socioeconomic drought, when systems collapse. The Ethiopian famine was all four. Modern climate science shows Indian Ocean warming can suppress East African rainfall. El Niño events can alter atmospheric pressure patterns. Deforestation reduces local rainfall recycling. In the early 1980s, these forces converged. The Earth's systems aligned against one region. When vegetation disappears, land degrades. Desertification is not a sudden event. It creeps. Overgrazed grasslands become bare soil. Bare soil erodes. Erosion removes nutrients. Reduced fertility leads to further vegetation loss. A vicious cycle. Parts of northern Ethiopia were already on the edge before the drought. When the rains failed, collapse accelerated. And yet, amid collapse, survival stories emerged. Communities shared food. Mothers walked unimaginable distances to reach aid centers. Doctors worked without rest. Volunteers buried the dead with dignity. Human resilience did not disappear. It intensified. In the harshest environmental conditions, compassion became a resource. It changed climate research. It changed humanitarian logistics. Early warning systems were developed. Satellite rainfall monitoring improved. Soil conservation programs expanded. Terracing projects began restoring degraded hillsides. Reforestation campaigns attempted to anchor soil and restore moisture cycles. The tragedy became a turning point. But the underlying vulnerability remains. Today, climate models suggest East Africa may experience more rainfall variability, more extremes, longer dry spells, shorter intense storms, which means the lessons of 1983 to 1985 are not history. They are warning. Water remains Africa's most strategic natural resource. Without water, soil fails. Without soil, food fails. Without food, stability fails. The earth is not cruel. It is dynamic. Rain patterns shift. Oceans warm. Atmospheric belts move. For millions of years, ecosystems adapted slowly. But human societies are faster and more fragile. We build cities. We expand agriculture. We multiply population. And when climate shifts, the shock is amplified. The famine was not just a tragedy of hunger. It was a lesson written by the atmosphere. A reminder that civilizations depend on systems larger than themselves. And when the rains fail, everything changes. The Ethiopian Highlands still stand. Volcanic. Ancient. Watching the sky. And the question remains, Will we build systems strong enough to withstand the next silence? Or will we wait again, for the rain? If stories like this matter, if you believe understanding Earth systems can prevent future disasters, subscribe to the Geologic Lens. Because the Earth is speaking, and we are here to listen.